Okay, so what number was this? 27?
Yeah.
So number 27 and 15.2 has this thing that I'm supposed to do. Okay, so they told me find a parabola. Y is ax squared plus b, right? Okay, so that looks like parabola, right? And it's supposed to best fit the point 1, 0 dot 2, 2 dot and 3, 4 dot, something like this. Okay, so obviously the kind of rando parabola I drew at first is probably not the one you want, right? So maybe the one you want looks more like, I don't know, something like that.
Those 3 points are on a line. Yeah, that's a big problem.
Yeah, those 3 points are on a line. I'm not going to be able to hit this with a parabola, right?
No.
You guys see that I sort of had to scoot this to the left. I'm not allowed to do that, right?
Yeah, it's just up or down.
You guys see that? So my blue parabola ain't going to happen either. So I just got to figure out how to get this best, right? So you might notice that this thing in here, right, a plus b is f of 1. If I thought about this as a function f of x, right? You guys all with me on that? Maybe that's f of 1 minus 0. This stuff here is f of 2 minus the y value associated. And this guy here is
F of 3 minus 4.
f of 3 minus the y value associated to 3. Right, so this s thing is a function of what variables?
A, B.
A and b, right? So s is a function of the parameters, and what it does is it tells you the squared vertical distance you are from your parabola to your 3 points. You guys see that? So I took the distance my parabola was from my first y value, squared it, added that to the distance my second point was from its y value, and so on, right? You guys cool with this?
Yeah.
So we want to make this as small as possible to get this thing to best fit, right?
Yeah.
So they could have really just said, meh, I don't need any of this stuff. Right? They could have just said, make this as small as possible. Right?
Okay.
Okay, so how do you minimize stuff? Yeah, take some partials. Okay, so I need S with respect to A. That's going to be a function of A and B, right? Okay, so what do you get? Ermengerd? 2 times A plus B to the 1 times 1. Okay, good. Plus 2 times 4A plus B minus 2.
Times 4. So 8.
Times 4 plus
2, 9A plus B minus 4. Times 9.
times 9. Cool. And yeah, I'll set that equal to 0 in a sec. What else should I get here? I should be looking also for SB, right?
So again, 2 plus AB.
Okay, so you get 2A plus B times 1 plus
2, same
4a plus b minus 2 to the 1 power times 1 plus 2 times 9a plus b minus 4,
Also to 1.
also to the 1 power
And 1.
times 1. Okay, cool. Before I go any place with these, I'm going to simplify a little bit, right? Oh, well, that's probably a better way to simplify. Let's do that. So let's trot this thing over. We're going to take 2 times a plus b plus 2 times 4a plus b minus 2 times 4 plus 2 times 9 times 9a minus b, whoops, plus b minus 4. Set this equal to 0, right? And then, what were you saying, Bria? Yeah, drop all that 2's out of there, right? Yeah, and then you need to distribute a little bit and combine like terms, right? So, ooh, sorry, how many A's? Oh, 98A plus 14B is 44.
You need one more factor of 2.
I need one more factor of 2. Where?
Oh, you can avoid that, right? You can divide another factor.
Oh, I can pull another factor of 2 out of this?
Oh, yeah, you can.
Okay.
I stopped there because it was
Oh, okay, because he's the one that's going to help. Okay, so if we divide by 2, we get 49 plus 49a plus 7b is 22, right? Okay, so that's what, this is really kind of what setting SA equal to 0 gets us, right? We get some line in A and B, right? Okay, and then out of SB is 0. Okay, so take 0, set it equal to this stuff. You got A plus B plus 4A plus B minus 2 plus 9A plus B minus 4. I dropped all the 2's, right? So I got 14A
Plus 3b minus 6.
plus 3B. Oh, good, and we'll just put the 6 on the other side. Right? Okay, good. So now this boils down to me having 2 lines, right? So I don't really actually need the partials anymore, so I'm going to dump those. But I've got 14a plus 3b is 6, and 49a plus 7b is 22. Now I just need to find the intersection, right? Okay. How do you do that?
solve for A, plug it into the equation, and then solve for B.
Yeah, you could do substitution, you could do elimination. Probably I'm going to do elimination because I'm too lazy for fractions. Okay, so if I'm going to do elimination, do you guys remember elimination? Yeah, kinda. I need to get 2 of the coefficients, maybe these 2, right? Equal with opposite sign. So this is 2 times 7, and that's 7 times 7, right? So what's this guy need?
7 halves.
7 halves. Oh yeah, sure, you could totally do that. I'm too lazy to do that. That's fractions. Multiply this whole thing through by 7, right?
Oh, and then at the bottom by
And then I'm going to multiply the whole bottom thing through by -2.
by both
Cool.
negative.
So, what do you get here? Quick, fast.
98.
Better be 98.
Yeah.
See, I shouldn't have divided by 2 up there. It's a terrible idea. So I got 98A plus 21B is 42.
Negative?
So the next one.
And then I'm going to multiply the other one through by -2, right?
So the top one was by +7 and then the bottom was by -2.
Yep. So I'm going to get negative 98A minus 14B is negative 44. And then I'm going to add those together. And I'm going to get what? 7B is -2. Correct.
You're gonna have the fraction anyways.
Bummer.
Yeah.
So B is -2/7, right? What's A?
Whatever.
Substitute B in and solve for A.
Yeah, sub B in. Where's a good spot to sub B in?
14A plus 3B equals 6.
Yeah, whatever your equation with your smallest coefficients is, probably, right? Okay, so take that,
But
jam
if-
that.
But if you do the other one, you get rid of your
Yeah, you
7.
can
Oh,
get
yeah,
rid
you
of
can do
that
it
fraction.
You have
7.
B.
Oh, dude, that's such a good
It's way
idea.
better.
Better idea. Let's take this and cram it in the second equation then. So we got 49A minus 2 is 22. So A is 24 over 49.
Oh, yeah.
Almost up.
Okay. Now what?
You just pump off those back into the original equation now? AX squared plus B.
Yeah, that's the thing that we're asking me to make fit, right? So I'd say y is negative 2 over 7. Oops. Why not?
Well, that's B.
Because that's b. Don't be a dummy, right? 24 over 49 x squared minus 2 over 7. Boom, boom. Answer? Yes? What have you screwed up? You all let me screw something up just now, and you're all like, uh-huh.
Wait, really?
What didn't I check?
You didn't reduce the fraction, did you?
No, who cares?
You didn't check to see if it's a max or a min.
Yeah, I didn't check to see whether this was maximizing or minimizing, right? I could have just maximized the least squares distance. Is that actually possible? Hell no. Right? So I don't care whether you actually go through like calculating D, and I just want you to have a justification for why the thing you just found is a minimum and not a maximum.
What would it look like if we tried to find the max?
Yeah, so what if we try to find the max? Well, remember, we're doing this thing, right? Like, we're taking these distances and then we're adding them together after we square. How would I make that bigger?
If only it's negative. Zero, right? Just like
Scale.
100, 1,000.
Yeah, or if it was negative and then you shifted it down.
Oh, just add constant to your.
Yeah, just like keep cranking on B, right? The bigger you make B, the further away this sucker is going to be. You guys see that? If you make B big and actually also make A big, right? Then this thing will not only be big, but also kind of narrow, right?
But what about
Oops,
this?
that got shifted off to the side. That should be.
What is it about that set of linear equations that forces it to be a min?
About this thing, right? This thing's a. Ooh.
That's the sum of the squares of the distance between the two the things.
But what else is it? It's a function of two variables, right?
It's a,
So when you took the gradient.
No.
If it's equal to 0, the critical point.
oh, you're right.
If so, just intuition wise, if you multiply all this crap out, right? I'm not suggesting that you do this, but if you did, what would you get?
0.
Parabolic.
I mean, you get like some a squareds, right?
Yeah.
Some ab's, and some
B squared.
B squared. B squared.
b squareds, and maybe some kind of goddamn number, right?
Yep.
What is this? This is a polynomial and two variables, right?
So it
That's-
Parabola.
quadratic, right?
Okay.
So it's a paraboloid of some kind. You guys see that?
Okay.
Okay, so if it's paraboloid, if it's pointed up, right, it's going to have a minimum. It's pointed down, it's going to have a
Max.
maximum. And if it's positive and negative, you're going to have
So,
some kind of saddle-y thing, right? So we could probably just figure out about the A's and B's what the coefficients are, right? I'm going to go ahead and guess that since I'm kind of positive, 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 right?
and it's all squared.
And I'm squaring everything, anytime I multiply an A by an A, right? It's going to have a positive coefficient. The B by a B is going to have a positive coefficient. I don't care about the other ones,
So this will always
right?
be.
Like this guy might have a negative coefficient, but the squares, the things that dominate, are going to have positive. So this is going to point up.
Yep.
You guys see that?
And that's how you know that it's a minimum.
And that's how I would argue that it's a minimum. I would say that thing's a paraboloid and it's elliptical, or at least it's not hyperbolic, because this coefficient and that coefficient are going to be positive.
What about if the original line had a downward slope? Would you want to use one that was downward facing just to match its slope better?
Yeah, if you found one that, right, if you constructed this thing, you guys see that? If you constructed this thing with a set of points that had a downward trend, you guys see that difference there?
It would still be a minimum, right? On the
Yeah, it would
square.
still be a minimum because the surface, right, would still be
The
a
least-
paraboloid, right? It's still going to be a least squares kind of thing. But if your dots go like this, right, what's the difference?
You have a maximum instead.
You could
You're-
shift
you're-
it.
This thing's still going to have a minimum, but your A is going to be negative.
You could shift
Yeah.
it to the right, couldn't you also? Just like make the paraboloid over here.
Yeah, that would probably be a better idea.
We're using just the ax squared plus b, which doesn't allow shifting.
Yeah, the
Just
reason they
using
did
the
that,
answer.
right, is that if you want to make a 3-parameter paraboloid, you need a surface of 3 variables, right? And then you have 3 of these partial derivatives to solve. And then it's not really that obvious that you're looking at a paraboloid because I don't really know what that analog is. You guys see that?
They only give us ax squared plus b to use.
They only gave you ax squared plus b
So if we
so that you would be living in like the normal R3 places. We could still do this problem with ax squared plus bx plus c. It would still work. We'd still do exactly this thing, right? We'd calculate the partials, we'd set them equal to 0, we'd chase it around until we found some critical points.
it just seems more,
Right.
more sense to make
It's
it
just
negative.
gonna be tougher, right? Which is why they gave you the kind of easy version.
I'm missing something. Where'd you get the ax squared plus b?
That was in the problem.
Oh, okay.
They said find the ax squared plus b that best fits these 3 points, and then they said, and you can do that by minimizing this S of AB thing, and they actually already gave me this formula, right? You guys cool with it? Okay.
Just making sure.